Welcome to SolveSpace tutorial number 4. It's going to be a housing fixture. And with that, let's get started. So we're going to start out by drawing some line segments. I always try to get them close to vertical or horizontal, but if you don't get them perfect, it's not a big deal. In this model, I'm putting in the chamfers automatically, or in the sketch. That way I don't have to, SolveSpace doesn't have a chamfer tool, so this is a good way to work around not having a chamfer tool. Okay, here I'm going to build in some intelligence here to the model to define the chamfer by making those equal. That sets a 45-degree chamfer here and there. Also set a 45-degree chamfer by making that vertical. That and that, make those equal, and then make them construction lines. Then we'll tie the two chamfers together since they're the same by pressing Q. Now let's see, let's get some dimensions. Okay, so that back part of the model there, that's diameter is going to be 25. The diameter is 25, so in SolveSpace you can dimension it by putting in the diameter over 2, which will give you the radius. And this point there is a diameter of 50, so click that point and that center line at 50 over 2. That broke the model since SolveSpace doesn't have an auto scaling function. If you change dimensions too rapidly or too drastically, it can break your model. It's just something to be aware of. It's not a huge deal, but can be a little weird. So yeah, this is just me fumbling through until I get orientation all correct. Okay, and we'll drag it roughly to the same shape. Now that back dimension, that is not what I wanted, not the distance between the two, but rather that distance there is 25. And from total distance front to back, you can select that point and this line segment here, and that will be a total distance of 40 millimeters. 40. And again, no auto scaling, so it broke the model, but that's okay, or broke the sketch rather. We can just drag it to where it looks okay and keep going. So we're going to dimension this point to that point. It's 3. There we go. Zoom in here. There you go. That looks good. So now we'll type in 12 here. And this is one thing I like about SolveSpace. If it can compute that dimension based off of other constraints that you've given, it will let you know by telling you that it's just a reference dimension. So the chamfers are changing here, so I know that's 1 degree of freedom that I need to constrain. So I go and I find the chamfer callout. It's a 1 millimeter chamfer at 45 degrees. So those are the same. We established that earlier in the dimensioning. So I type in 1.0. Okay, and then we just need to establish that diameter, which this is a mistake I made. Realized I should have typed 12 over 2 since it gave the diameter on the part, but again, with most of these tutorials when I make mistakes, it's more about the workflow than it really is the true dimensions. Now, if it was a functional part, I would discover that error, hopefully before it was too late upon review or something. But anyway, so now I'm going to put these holes in here. And with most modeling, at least in the professional world that I've seen, putting in actual threads is more of a cosmetic thing than anything else. So I don't bother. With SolveSpace, there is the ability to do threads, and I do plan on making a tutorial that shows that capability. But for now, on this guy, I'm just putting in the symbolic measurement of what the threads should be, which is 3 millimeters. That's coming up here shortly. So this is a 40 millimeter circle. Make sure that it's a construction line. And that will constrain this point, which is a 3 millimeter hole. So M3. Which, thinking on it now, an M3 probably doesn't have a 3 millimeter hole. It's a 3 millimeter shank. So what you would need to do is look up a tap chart, and then you could go from there. I don't normally work with metric, so I'm not sure what a normal minor diameter for 3 millimeter threads would be, but again, it doesn't particularly matter, so we'll ignore that. We basically just made that a symmetric thing, dimensioned it to 12 millimeters. Since it's fully constrained, we'll make this a difference. We'll go select that point, constrain it to this back face here, press O, and then we're pretty much finished. So we'll go home, hide all, and aside from that extremely large button in the front face there, it's and the wrong size diameter holes, it's a complete model. Thank you very much, and I'll see you next time.